All right. Well, hopefully you had some luck doing those problems, and if you want to send me a draft, that's obviously good as well. Let's move to the next part of this. Interesting situation, and as many of you know, I do research with asthma, so it's Roman numeral 3 here. Let's say, for the sake of example, you take 3 people with asthma, and you design a program, like I do, to help them with their asthma. And with these 3 people, you measure their quality of life. So quality of life, we're saying, is on a 15-point scale. Higher number means that they're doing better with their asthma, better quality of life. And let's say you measure them in the way that I've shown in A here. And so you take them, and notice you've got 3 people before. Person 1 has a score of 1 before. After, post, they have a score of 5. Person 2 has a score of 4, and then they go up to a score of 9. And person 3 has a score of 7, and they go up to 13. The question is, for this particular situation, number 1, what would be the appropriate statistic to use? I'm taking people before and after. Notice how many times I'm measuring people here. I'm measuring the same people 2 times. So you basically have one independent variable here. What we usually call this kind of design, when you have one independent variable like this, you might call the IV, which is a general category name, time of testing. How many levels do you have? 2, pre and post. And then the question is, how many times do you measure people? Well, you're measuring people twice, before and after. Could I actually do an independent samples design on this? Hopefully you would answer no. This brings us to Chapter 11. Chapter 11 shows us another very useful type of statistic that we traditionally use in psychological research, and it's called the t-test for 2 related samples, often called a repeated measures design. In this particular design, I often call it an intervention design, because I'm taking the same people and measuring them first before I do anything, and then after I do an intervention. The intervention is almost in the middle. In this case, in my asthma study, I run a paired t-test because I measure them before I do anything, and then I put them through an 8-week program, and I measure them again after. So this is a specific situation where I'm taking 3 people, measuring them before, and I'm measuring them after. So this is called a paired t-test design. If you open at the beginning of the chapter for each one of these 2, it says this. You're measuring the same subject. It's a within subject design. Sorry about all the names. And you basically measure people before and after. Looks like in example 11.2. For both books, they give an example before and after medication. So this is very popular to look at the effects of a behavioral intervention, in mine an asthma study, or even in the effects of diabetes, heart disease, giving people medication and measuring them before and after. The reason this is such a popular type of design, and I want to really share with you some 2 key things here. One of the reasons I really love running this type of design with research that I do is, number 1, you need less people. If I have 3 people here, if this is an independent sample, how many people do I need? I need to recruit 6 people. Now that's not a lot, 3 or 6, but when you're running a big study, it does make a huge difference. So usually to do a paired sample t-test, which is what you would do in this case, you have 2 groups, a before and after, you need a lot of people, but if it's a paired t-test, you need less. So that's one big advantage. But the other, and the most important advantage of doing this paired t-test design, take a look at these 3 people and what they actually do in this study. Let's say that it was an asthma program and it was designed to teach people about asthma. Look at how these 3 people start. Subject 1 comes in, and how is subject 1 doing at the beginning? They're doing horribly, right? Their life is very bad. Their asthma is probably very severe. Look at how subject 3 is doing. Their score is a 1. Look at how subject 3 is doing. Subject 3, at the beginning of the study, actually is doing reasonably well. They're doing 6 points better than subject number 1. The nice thing about the paired sample t-test, the nice thing is it doesn't matter where people start. What's really nice about this design is it does not matter where people start. What matters is the amount of improvement in the program. So the big statement that we often make about the paired sample t-test is that individual differences are removed. So if you're somebody who starts in a weight loss program, let's say, and you start off like me and you're maybe 15 pounds overweight, maybe you weigh 180, and you're somebody else and you start off maybe 250, that doesn't matter. Individual differences don't wreck the statistic. Instead, what actually matters is how much does this program help people? How much does the program help people? Now take a look for subject 1. How much did this program on a 15-point scale help subject number 1? Well, it looks like it helped them by 4 points. How about subject number 2? How much did the program help them? By 5 points. How much did the program help subject 3? By 6 points. If you average all that together, what is the amount of the program helping? Well, 4, 5, and 6, the average is 5. Do you think that's going to be the numerator or denominator for this t-test? That, in fact, would be the numerator. And if you look somewhere on here, you'll basically see this. If you look on the second table, under the mean, do you see where it says -5? You could write that as +5 if you wish. What you basically do to get the treatment effect is you get the mean of the first column, it's a 4. The mean of the second column, it's a 9. And the treatment effect is 5. This program on a 15-point scale is helping people on average by 5 points. So what we really like about the design of the paired sample t-test, it doesn't matter where people start. What matters is how much does the program help each individual. When you do the independent sample, that you can't say that. If you have a lot of individual differences, they can really wreck the independent sample design. But when you do a paired sample t-test, because you're measuring a person twice, their baseline is kind of their start point. You can see just how much they get better. So that's a huge advantage. Check in your book for some more details about it, but it makes it because you need less subject and you can be more sensitive to see how much somebody improved. You can look at it. So we like to use this one a lot in psychology. So let's go over the data here and see what we actually have. If you look at the first example here, we've got the pre-line. Notice the mean is 4. You have 3 people. Could you figure out how they got the standard deviation of 3? You take a 1, 4, and 7. Can you get the sums of squares there? It looks like it's about, 18. Variance would be 9. Square root of 9 would be 3. Standard error of the mean, how do you get that? 3 divided by the square root of 3. Can you write out the math to figure out the post scores? It should be pretty comparable there. That's why we had you do that on week 2. So the top table you should be able to figure out. Let's go down to the bottom table. It looks a little different, but there'll be some commonalities here. Let's start off with the column that says mean. That's going to be the numerator of the t-test. So the mean difference, the treatment effect, is 5. Can you figure out which number will be the denominator for the t-test? Hopefully you figured out that this is the standard error of the mean. So if you put 5 over 0.57, you do the math, you do the hokey pokey, you turn yourself around. Wonder if hokey is for, well, never mind. Put 5 over 0.57 and you should get a t-score of what? 8.66. Don't worry about the other columns for now, but get a t-score of 8.66. According to this data, how often will you get a t-score of 8.66? It tells you you will have that happen basically 1 time out of 100. Is that significant? Yes, it's less than 0.05. So if you had to write out the t-score, could you do this in APA style? T, how about the degrees of freedom here? What does it tell you here? T, and then in parentheses 2. How come it's only 2 here? Well, you only have 3 people, so it's the number of people minus 1. So T2 equals 8.66. Then you write comma, P equals 0.01. Statistical conclusion, significance. Real world conclusion, the Tausman asthma program looks like it helps people out, that people are better at the end of the program. So hopefully you understand the paired sample t-test for this. I'm going to ask you to do a homework example here. See what I got here. Paired sample here. 1, 4, and 7. 2, 6, and 10. So you have to get a mean for the top table. Hopefully you can do that. Hopefully you can get that mean on the bottom table in pretty good shape. You can figure out the degrees of freedom, the t-score. and then also it looks like I give you the significance to see if you can write out statistical and real-world conclusions. Thank you all very much. Work hard on this, and we will pick it up on the following week. Thanks. Bye-bye.